This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. In this video we're going to go through another couple of important theorems. The first has to do with parallel lines, the second has to do with ratios in a triangle. You might recall if we have parallel lines such as these here, and what we can do is we can draw a transversal, which is just any line that cuts these three parallel lines. But the important theorem we need to know here is that if a transversal is cut into two equal parts by three parallel lines, then any other transversal drawn between these parallel lines will also be cut into two equal parts. So in our example over here, if we first drew this line here, and we knew that the two lengths here and here were of length 3, so they were equal, then if we draw any other transversal line, like this one here, or this one here, they will also be cut into two pieces. At higher level, you may be asked to prove this theorem, and that will be shown in another video. The next thing I want to talk about is this theorem here, that if we have a line that is parallel to one side of a triangle, cuts the other two sides of the triangle in the same ratio. This ratio is often referred to as m/n, and there are several types of questions we can be asked to do with these. The first being that at higher level you may be asked to prove this theorem, and again that will be shown in another video. But if we were to come down here and take a look, for example, at this triangle here, we see that we have drawn a line through the triangle that is parallel to the line BC, and what we have to realize is what we can write, which is sometimes written as part over part equals part over part. That may seem a bit odd, but what that means is if we take one part of this line that's cut in two here, AX, and we divide it by the other part of the same line, XB, that ratio will be the exact same as the ratio of AY divided by YC, or the top length divided by the bottom length on one side is equal to the top length divided by the bottom length on the other side. And we can also flip these fractions the other way around and write that the bottom length divided by the top length is equal to the bottom length divided by the top length. So in our triangle we have over here, our bottom length is XB divided by AX is equal to YC, our bottom length on the other side, divided by AY, the top length on the other side. The next thing we'll take a look at, and another way of writing these ratios, is instead of saying part over part, what we can say is part over whole is equal to part over whole, or what we can say is that the whole over part is equal to the whole over part. Just flipping that around. But what do I mean by that? What I mean by that is if you take that same triangle and have it cut by this line XY, then the ratio of the whole length to a part of the line will be equal to the ratio of the whole of one of the other lengths divided by the corresponding part of the line. So in this example here, what I've taken is the overall length of this left side, AB, divided by the length of the bottom piece, xb. I could have taken the length of the top piece either here, just to make note of that, but I'm just going to go with the bottom piece. So the length of the whole line AB divided by the length of the bottom piece XB will be equal to the same ratio on this right hand side, so the whole length AC divided by the bottom length YC. So that's overall length divided by part, or whole over part. But what about part over whole? Well, we can do that too. Instead of looking at AB over XB, let's look at the bottom piece XB divided by this whole length AB. Well, what's that ratio equal to? It's equal to the same ratio on the other side, so the bottom length YC divided by the whole length AC. And these ratios can appear from time to time in various questions.